Differentiate between physical and chemical properties of a substance. The physical properties are things like the color, the texture, all of those, the boiling point, the melting point, those kind of things. The chemical properties is how they react with other substances. Differentiate between physical and chemical changes. Physical changes generally involve energy, but the particles themselves do not change, whilst chemical changes involve a making and breaking of bonds. Now, energy changes would be things like melting and boiling, but making and breaking of bonds would be things like hydrogen and oxygen getting together to make water. Right, I think we should know the three phases of water: solid, liquid, and gas. What causes a substance to evaporate? Energy is added, and then it causes the particles to move more, and then finally that causes it to change from liquid to gas phase. What causes a substance to condense? It's exactly the opposite. So what are you going to do in that situation? You're going to say that energy, it loses energy, and then the particles move less, and it changes from a gas to a liquid. Define melting point and boiling point. Melting point is the temperature where a solid turns into a liquid. It is a specific temperature. That's the very important thing. And a boiling point is also a temperature where a liquid becomes a, oh sorry, that's a bit messy. It's where a liquid becomes a gas. What type of motion do the particles of a solid experience? Only vibrational. What type of motion do the particles of a gas experience? They experience vibration, translation, and rotation. What is translational motion? It is moving from one place to another. Which phase of matter has the strongest forces of attraction between the particles? That would be a solid. Which phase of matter has the weakest forces of attraction? That is a gas. Therefore, it's got the strongest forces of repulsion by virtue of that. Complete the table below. So, if we have to talk about the arrangement of particles in a solid, they are regular or fixed. In a liquid, they are random, and in a gas, they are random. The spaces between the particles of a solid, very small. Liquid, small. Gas, large. The motion of the particles in a solid, vibrations only. And then with a liquid and a gas, it's vibration, translation, and rotation. Vibration, translation, and rotation. The attractive forces in a solid are strong. In a liquid, they're also quite strong because they stay close together, and in a gas, they are weak. The repulsive forces in a solid are weak. In a liquid, quite weak, and in a gas, strong. Compressibility, none. You can't squash a solid anymore. Slight. In a liquid, you can compress it just a little bit, and in a gas, big, huge, significant. Diffusion. Remember what diffusion is. It's the moving of particles in between other particles. So again, in a solid, none. In a liquid, it is slow, and in a gas, diffusion is fast. The particles move in between each other. State the law of constant composition. So, the law of constant composition says that a certain chemical compound always contains the same element chemically combined in the same proportion by mass. What mass of oxygen would combine with 2 grams of hydrogen to form water molecules? Well, we're going to need a balanced equation first. So we're going to give hydrogen plus oxygen gives me water, and I need to balance that. They want 2 grams of hydrogen over here. We know that the molar mass of hydrogen is 2. So we're going to land up with 2 over 2, which is 1. The mole ratio is 2 is 2. They're needing oxygen over here, 1. So it is a 2 is to 1 ratio, and therefore it is going to be 1 is to 0,5. So the molar mass of oxygen over here is 32, and therefore we can say 32, and we halve that, it's going to land up being 16 grams of oxygen over there. What mass of hydrogen would combine completely with 64 grams of oxygen? So now I've got 64 of oxygen. Divide that through by 32, and I find that I've got 2. My mass ratio is a 2 is to 1 ratio, which means that I'm going to have to double for the hydrogen, and that means I have to double the 2, so it's 2 times 4, which is equal to 8. So you'd have 8 grams of hydrogen that you would need in a ratio with that. State the law of conservation of energy. Energy cannot be created nor destroyed. It can only be converted from one form to another. Differentiate between endothermic and exothermic reactions. Endothermic reactions will get cold firstly. So endothermic gets cold because it takes in energy, whilst exothermic is exactly the opposite. It gets hot because it releases energy. Differentiate between synthesis and decomposition. Synthesis is when 2 or more atoms or molecules join to form something new, whilst decomposition is exactly the opposite of that. It is when a molecule is broken up into parts of some sort, either molecules or atoms. An electric current decomposes copper chloride into copper metal and chlorine. Write a balanced equation for the reaction. We're going to say copper chloride, which is CuCl2 because it's got a valency of 2, breaks up into copper metal and chlorine gas. Iron and sulfur are synthesized into iron 2 sulfide. Write a balanced equation for that. So we're going to have iron plus sulfur joining to form iron 2 sulfide. Sulfur's got a valency of 2, iron has a valency of 2, so it is FeS. Differentiate between an element and a compound. Give an example of each. If we're differentiating between an element and a compound, then we're going to say an element comes from the periodic table. Oh, that pen's a bit fat. Periodic table, and a compound is when elements have joined together to form a new molecule. So it's elements together with a new molecule. Differentiate between an atom and a molecule. An atom is the smallest particle of an element, whilst a molecule is the smallest particle of a compound. Oh, we have to give examples of each. So an element would, let's say, be gold, and a compound would be H2O, and a atom would be a gold atom, and a molecule would be an H2O molecule. Differentiate between a pure substance and a mixture, one type of elementary particle. And that elementary particle can be atoms, it can be ions, it can be molecules, any of those. So that's a pure substance, whilst the mixture has more than one type of elementary particle. And if we want a pure substance would be something like water, whilst a mixture would be sand and water. Differentiate between homogeneous and heterogeneous mixtures and give an example of each of those. Homogeneous, all in one phase. Heterogeneous, different phases. An example of a homogeneous mixture would be, let's say, salt in water. You can't see the difference. Whilst sand and water or oil and water would be heterogeneous. Differentiate between miscible and immiscible liquids. Miscibles can mix. Immiscibles can't mix. And an example of immiscible liquids would, let's say, be alcohol and water, whilst immiscible liquids would be oil and water. Differentiate between a suspension and an emulsion. A suspension is solid particles in a liquid, whilst an emulsion is liquid droplets in a liquid. And that would again be if you shook up oil and water, or if you could do cream in milk, whilst the suspension is mud, for example, because it is sand in water or something like that. How can alcohol and water be separated using fractional distillation? So we have to raise the temperature to about 78 degrees centigrade. That's the boiling point of alcohol. The temperature will then stay constant whilst all the alcohol boils off. You would use a Liebig condenser to recondense it and collect the water. And then when the temperature went to, then raise the temperature to 100 degrees centigrade, and it will stay constant, and you use the Liebig condenser again. So basically at 78 degrees the alcohol becomes a gas, and then you use the Liebig condenser to make the alcohol a liquid again. And the temperature will stay constant as long as that phase change is going on. And then the same thing you do with the water. Define the following words: ductile, malleable, lustrous, and sonorous. Ductile means I can draw it into wires. Malleable means that I can hammer it into a shape. Lustrous means that it shines. And sonorous means that it can make a ringing noise when hit. And those are all properties of a metal. The ductile, malleable, and lustrous all have to do with delocalized electrons. Ductile and malleable, the delocalized electrons continue to attract the lattice together. Lustrous, those delocalized electrons jump up and down and everything, and in doing their jumping they give off a shine. Which metals are magnetic? There are only three. It is nickel, cobalt, and iron. Use the model of metallic bonding to explain the electrical conductivity and the malleability of metals. The electrical conductivity, you need to discuss the C of delocalized electrons that are free to move. And in terms of malleability, the sea of delocalized electrons are flexible, and therefore they are able to hold the lattice together, even if it changes shape. Use the model of metallic bonding to explain why metals have a relatively high boiling point. I'm not sure what the word was, it rubbed out. Have a relatively high boiling point, and that is because there are strong electrostatic forces, and this is an important thing. Strong electrostatic forces. Where do they come from? Between the positive kernels and the sea of delocalized electrons. And therefore it is difficult to, or need lots of energy to, separate that. To break apart lattice.